welcome to my presentation, Cloud-based Web Service for Outlier Analysis in Environmental Time Series served via SOS. My name is Doron Goldfarb, and I'm working at the Environment Agency Austria as a member of the European Long-Term Ecological Research Infrastructure and Community. We maintain a research site in the Alps, and through that activity, we are of course dealing with ongoing issues about digitalization of research processes. And in this context, we are participating in a number of EU projects. One of these projects is called EOSC-HUB. It's dedicated to the emerging European Open Science Cloud. And as the name implies, it's about sharing, so kind of research infrastructures and communities sharing their services and data products across Europe. And so our experiment or prototype web service can be seen in this context as a kind of a contribution to this European Open Science Cloud. So the background is, as most of you might know, research infrastructures seek to provide standardized facilities, resources, processes, and services for specific research domains, such as in our case, long-term ecological research. And ongoing digitalization puts the focus on data aspects across the whole life cycle, ranging from measurement to transformation, processing, and publishing. And as far as publishing is concerned, cloud data repositories are increasingly used for sharing and publishing data. And in the context of time series, environmental time series data, SOS is of course a natural choice, since they're also kind of geo-referenced, coming from specific research sites. And in this case, of course, considering contributions by many different members of such research communities, the data quality assessment is, of course, an important aspect of high relevance within this research infrastructure, but of course also beyond the immediate community, considering endeavors such as the European Science Cloud, which are about sharing the data across or beyond one's immediate community. Just a few words about the eLTER-related. It's a very recent addition to the roadmap, to the S3 roadmap, dedicated to long-term ecosystem, critical zone, and socio-ecological systems research. The mission is research into ecosystem structures and functions, and it is site-based, multi-scale, and cross-disciplinary. And it features a systematic coverage of major European terrestrial, freshwater, and transitional water environments. And it's about 250 selected research sites out of a pool of more than 400. One important part of the eLTER is the so-called eLTER service portal, which is dedicated to providing access to data and site information. And there are a number of key platforms in this regard which should be mentioned. So first, we have DIMES SDR, the DIMES Site and Dataset Registry, which mainly provides metadata about all the research sites that are kind of available in the eLTER context, also beyond the eLTER-RI, so it currently features about 1,000 sites. Their location, extent, what kind of parameters are measured there. Then we have the data integration portal, eLTER-DIP. It's mainly some kind of search interface for finding data made available via very heterogeneous ways. So we have, on the one hand, we have SOS-based data. On the other hand, we have file-based data made available via cloud repositories, for example. And as far as SOS is concerned, there is the so-called Central Data Node, which is a service offered to eLTER members who don't maintain their own data provision portal. And it's an SOS-based approach to provide time series data. And one significant development which is taking place right now in context of the eLTER Plus project is the development of so-called virtual data labs, which are mainly currently envisioned to be based on Jupyter Notebook, for example, like reusing the data offered via CDN, for example, and other sources to do research. And of course, in this context, as mentioned before, outlier detection is of course crucial. Considering the aggregation of data from different sources, it's a prerequisite. And outlier detection is an important aspect of quality assessment in general. And here we should probably say that, of course, it's very important to separate technical reasons for having outliers. So when the measurement is incorrect or kind of simply not taking place due to covered sensors, overflowing containers, bad calibration, and so on. And then from outliers that are based on unusual events or observation, which is kind of high wind speed or high temperature during specific environmental situations. And of course, there are of course different specific malfunctions can be flagged right at the beginning when recording the data, while other outliers would have to be detected using a kind of one of many different available methods. And so in that case, of course, considering individual researchers or measurement sites using probably very different methods to detect outliers, it's of course a strong desire to standardize such approaches within the same research infrastructure. And so this led to the idea of creating a kind of a centralized outlier detection service for the ELTER-RI, in order to support data aggregation for standardized ELTER-RI data products, but also offer a general quality assessment service for data providers, even beyond the ELTER research infrastructure. And the one specific idea behind it is, of course, to provide a standardized array of outlier detection methods with a non-black box philosophy, so to say. So it means that to provide a transparent array of methods to describe them, to describe their pros and cons, and also kind of to allow a centralized maintenance and thus provide a lower usage threshold by providing a good documentation also for that methods. So the idea is, first of all, to reuse existing methods that are made available via R packages, and in that case, to provide RScripts, which perform the basic steps of retrieving the data, of processing the data, annotating the data with the detected outliers, and to encapsulate that workflow behind the REST API, and to provide access to data, so to kind of offer commands to tell the RScript to either derive the data to be analyzed from SOS or from file-based cloud repositories. And of course, the advantage in this regard would be that on the one hand, you would offer a service, we could offer a service. And on the other hand, the RScript environment should also be can be operated independently, downloaded and used offline. And one specific issue has been mentioned before, data provenance is of course of increasing importance. So one definite important aspect of providing a centralized service would be that that data provenance can be tracked or provided as well, what kind of methods were used, where outliers have been detected, and of course something that cannot be tampered with. Of course, probably in our context is less of importance in this regard, but of course it would raise trust in our data products when you know that they are annotated by a standardized service. Okay, so the idea is to encapsulate the RScript behind the REST API. Many of you might have heard about the so-called OpenAPI specification, which is an approach to standardize the description of REST APIs. We use that, so it's based on a JSON or a YAML description of the functions that the REST API should provide. And the idea is to provide such a standardized description, which can then be used to automatically generate server stubs for many different platforms. In our case, we use a framework to automatically create a Python-based web server. And here you just see there is an online editor available, which you can, but not necessarily have to use to create these descriptions. The practical thing is that there is also some form of auto-generated documentation for this API. And basically, so we offer two main functions. So one would be to retrieve data via SOS. The other one would be to retrieve data via file-based repository. Of course, in that case, we would have different parameters. For SOS, we would need feature of interest, procedure, and so on. And for file-based repositories, usually just the location of the file would have to be passed. And then we have two separate kind of ways how to process the data. One would be the synchronous way that you kind of wait for the results. So you just issue a request and then you kind of block your application that calls the REST API would block and wait for the result. And in the asynchronous case, you would just kind of trigger the processing and then poll for the status of it. So here it's kind of a pretty simple diagram showing the structure of our service. So we have kind of the caller is calling the web server, which constantly runs, of course, and so each request would trigger the creation of a virtual RScript environment, which then starts its processing, retrieves the data in that case from SOS, waits for until it's returned, and runs the outlier detection methods, and then returns. And only when the information is available, the calling process can continue with its task. And so, of course, there is this more complex case because I will talk about it later. In some cases, it takes quite some time to perform an outlier analysis, especially when using an array of different detection methods. So this called for the implementation of an asynchronous way to call that. In that case, you can see that we have the similar workflow as shown before, with the difference that the web server kind of waits until the RScript finishes and stores the information collected from the RScript in a file, and also maintains a kind of information file about the status of the process. And there is a dedicated function which can be called to poll this file, and so that the calling process can do something different in the meantime, call other things, and then kind of see when the data is available and finally download it. Regarding the outlier detection, as I said before, it's about the first approach is to use methods which are available via already existing packages. Basically, one parameter that the users should provide is kind of the size of a moving window. And the interval this window is applied to the outlier detection, and currently there are 9 different methods implemented which are all called together. So right now there is no approach to, or no parameter to select which one. So currently all the 9 different methods are run, and the annotation for each value would kind of consist of 9 flags saying that this method X has found the outlier here. So this is, of course, a work in progress. So currently, these are also kind of univariate methods mainly. And of course, the idea is to extend it also via kind of asking users what they would like to have. The results, once the script the outlier detection is finished, are currently also only provided via a zip file. So on the one hand, it contains the time series data annotated with flags, as mentioned before, but also additional files showing more detailed information returned by the individual outlier detection methods. And especially for the windows, in which moving window this outlier has been detected. This is also mainly for kind of estimating the accuracy of that outlier detection method. And we also provide kind of simple Jupyter notebooks at the moment that are GitHub repository showing how to call that API and how to do some simple analysis of the results. As far as the lessons learned so far, so kind of having the idea to provide a generic outlier detection web service that retrieves data via SOS, of course, raises a number of issues. For example, how to identify individual time series in SOS. So we ran into that. So we kind of tested a number of different SOS endpoints, and of course soon realized that there is no unique way how to identify one time series. In one case, it could be just the parameter, the name of the parameter, the location, and begin and end time. In other cases, it could be that you would need an additional procedure information because there might be different procedures applied at the same location, at the same point. And then in other cases, such as the ELTER CDN, currently there is an individual offering for each time series. So this is, of course, configuration dependent. There is no universally valid approach, and this is potentially, of course, problematic for a generic application, because, of course, you would have to know what kind of information to provide in order to retrieve that data. And here, especially in the context of LTR, this, of course, raises the issue that we should use a dedicated profile as it is already available, for example, in WaterML. And this is definitely something that should be followed into the future. And another issue is regarding performance. So as you can see here in this graph that I created, there is a linear increase in retrieval and processing time. But as you can already also see, the Outlier, the SOS retrieval itself is a kind of 2 orders of magnitude lower than the processing time. So the main issue here is, of course, the time that is needed for running all these different outlier detection methods. And so this is definitely something which should be followed in future regarding parallelization of these calls, because this is something which definitely made us to consider this asynchronous retrieval, because this is kind of quite a long time. And another issue would be to consider caching of results of already annotated series, but there are other issues. For example, one could also consider how to feed back the results into the original data provision. So this already kind of brings us to the outlook. The services plan to play an important role in the emerging ELTER-RI, and to fit into the workflows that we kind of currently create. And in that case, it's of course very important also to consider provenance. Future work will include the additional evaluation of outlier detection methods. And in this regard, of course, caching and performance improvements will be crucial. So thanks for your attention, and I'm looking forward to your questions.
Thank you, Doron. Very impressive work you've achieved with the SOS and R in combination. So I would open the floor to questions. Raise your hands, put something in the chat, or you can also just unmute yourself. So until people thought things out, I have at least one question. I dropped out of the Zoom session, so I might have missed it, but do you use the SOS4R package?
Oh yeah, sorry for not mentioning that. Yes, exactly.
Great.
We use the SOS4R package.
So, that's
I
cool.
should have mentioned that, sorry.
No problem. If you have any feedback on that, we would be very happy to receive some, because yeah, we obviously want to improve that if there is something that can be improved.
Yeah, I think my colleague already got in touch with the developers for 1 or 2 times. And yeah, so we will definitely continue working on that, and I'm sure that we'll get in touch with you also. Great. Probably regarding some questions.
Cool. And the other question is actually really on what you already talked about regarding the concept on what defines a time series within the SOS. So we have a similar, I wouldn't call it a problem, but a similar situation where we want to harvest data of SOS instances into a registry, a catalog service, something like that. And yeah, we encountered similar issues with different SOS instances because they are set up in a very different way, and you really don't know, or there are so many multiple ways on defining a time series. So maybe we could have a chat on your insights, and we can share our insights. I guess Simon Jirka is the perfect colleague to have a chat about that. But I know that it's an issue, at least on our side as well.
Yeah, sure. So I think this is a general pitfall of once you want to offer a very generic service, you would run into giving people the freedom to configure it in very different ways. So I think the approach via profiles is very promising. I think that's as I could see, you already started to work on that, and I'm sure we would be very interested in contributing to additional work here.